Hi all, thanks for joining. I'll just start in 5 minutes. Wait for me to share my screen. So my screen is visible now. One of you can just quickly wait. Tell the alarm mics. Yeah, I guess. Is my screen visible? Okay, thanks. So this is, I guess, our week 11. We probably have one more week and an extra session if you would guys like to continue. So that's it. And then after that, you'll have So we are back again for the course of Data Analytics with Python. I'm Jagriti, TA for NPTEL PMRF TA for this course with Professor A. Ramesh. So last week we saw different type of clustering techniques. We saw how different distances methods were there, Manhattan, Minkowski, and then we have a Euclidean as a regular one. Then we also saw a region of conversions, and again we went through the metrics again. So we had this accuracy, sensitivity. So it's like we just went through them. It's like what were the crucial parameters, and while doing the assignment what should be important to take care of it. So we looked through lecture, I guess, 47 and 48 more closely, because it had some of the functions also written for the Python scripts that you need to know actually, that okay, while performing a function, these are the basic functions that you need to know. So those were the things that we did last week. Now, after last week, we, I guess, completed all of the part from it. Now, next week is all about cluster analysis. We'll complete forward on it. So now in cluster analysis, it's just that now what if you're something you're trying to cluster, you're trying to make some groups in between two different, you're trying to segregate your data into two different groups. Now, what if you have some missing data? What if your data is not following the trend that you have? Is like all of the data points do, but there's one outlier in your data. So that outlier we usually consider as standard deviation or something. If there's a group of them, then we'll consider the variance by considering the dispersion of the curve. Then after that, how do we look at it? Okay, then we saw differences in between. For clustering, I guess we did something as there was something as supervised and there was something as unsupervised. So we saw that okay, when to which to apply and when. So for this week, it's will more closely follow on k-means. The towards the end, it will be everything on k-means, and we already had a look on k-means. What k-means was, yes, we actually didn't follow k-means as name of it, but we did look at clustering two different groups with respect to the centroid of it. So where the centroid of that particular group lies in. So I guess I introduced that when we were directly starting cluster analysis in the last week. So for this week, the agenda is like first lecture states will handle some missing data values, and then we'll calculate the similarity and dissimilarity matrices. So what are these matrices? Some of you who might have went through the lecture slides, you might know that okay, we'll just see the some similar values that are there in the matrix. Dissimilar values is like one minus those particular similar values, or it can be the values that are not matching, or the values that are like causing your data to not follow a particular trend that you are trying to. Now, sometimes what happens, this missing data can be because it can be because of a person's variability, can be because of the errors that are there in the measurements, or can be that someone actually missed to acquire that particular type of data, or can be due to the time that is being fallen through. So that's just building up motivation. So then how do you handle that particular type of data? So let's say you don't have any data in that sheet. Let's say you have values from 1 to 10, but somewhere near 6 or 7th value you don't have anything. Now you can't just directly put 0 in there. When you do stats, it's very important to have your total number of count of variables that you have. So let's say you have 10 number of variables, but instead any particular variable, let's say in position 6 or position 7, let's say in position 7, you don't have any variable, you don't have any information for the same. So your total count for doing any further measurements won't be 10 anymore. It would be considered as 9. So you'll always consider the total number of physical elements that are not missing, that are present in front of you. So the quantitative values of the metrics or the parameters that you will consider there. But if something's missing and you want to replace it by some another value, so how do you handle those another values? You can simply add the mean of your entire data set as that particular value. So that is also one of the way where you can handle the missing data that is there in your data set. Again, same thing. So let's say if it's a matrix, then we can handle it by means of code. Let's say we added some mean, median, mode, or something of the surrounding variables. Let's say I have a 4 cross 4 matrix. Now for this particular value, this value was missing for me. So I can do something as average of this to variable, average of this to variable, compare that particular value, add that value in here. So we can do something, but we need some references, we need some proof backup to proof it up that okay, we did using this method and that method is something like. But let's say you don't have any method, you don't have any information about the data that was there, or you don't have any prior data that how it actually would be, then what simply you can do is like you directly delete your data, delete that particular point, do not consider that point in your measurements, and simply let it be. So that is why a variable that is missing will have to be removed too. So you directly exclude it from your data analysis. Do not consider that variable. Let's say I made, so someone is doing some experiments, and one particular day he did something like three set of experiments. He did three measurements. He was doing in let's say any particular experiment. He did three sets. But from that particular three sets, he wasn't able to get his like, let's say, I won't say good data, but in one set of experiments his data was way different with respect to another set. What thing he can do is like he can repeat his experiments for two more times, or what else he can do is like he can remove that particular data value from its measurements. But now he only has two, and what we learned from stats so on, we cannot do any statistical analysis in between two samples or two data sets. We need to have at least 5 points in it. Now, those 5 points can also be three. So we can do stats in between three data points. But if you only have two, you cannot do any stats. Any of the method that we have till now won't work for two data points. For test of normality, for test of significance, population proportions, any of the test. So for that, you can just repeat your experiments to 5 times, or you can reduce it, and you won't say that, okay, it is following. What option would be with you was like, you can compute the mean of your data, you can compute median of it, mode of it, but your variables, your quantitative data won't have that strong value in it. Okay.
Ma'am, I have one question.
Yeah, yes, go on.
Ma'am, what is the main purpose of clustering?
Sorry.
Ma'am, what is the main purpose of clustering?
Yeah, so if I give you an example, if I have, let's say, I have a disease group and I have a normal group, I did some measurements of both of them. Now, through my own techniques, I want to show that this particular two groups are different from each other. So their clustering will help me to differentiate that one plane of difference in between the disease group and a normal group. But how to do that? That things that we are learning over here. So when to make a cluster, when not to make, always depends on your research question that you're trying to ask. Okay.
Okay, ma'am.
So same way that if you don't have any particular value in your data set, and if you want to standardize your data, take a mean value of your data set at that particular nth value, so that your entire data set's mean won't differ even if that particular value went missing. Okay, so you always consider the n number of variables as the non-missing parameter values. That is the physical values or parameters that you have with you. Okay, and not the missing ones. Okay. So same thing, how to handle those, and we'll compute the distances here also. Now here the distances are always based on Euclidean distances, or it is based on if that particular variable is present or not present. Okay. So we'll just directly see. There's something another that is termed as dissimilarity. Now dissimilarity here is that particular is like, we are not speaking of distance here, but we are looking at the variations that are, is like, if your entire data set follows a one trend, this particular value or a parameter that won't follow that particular trend. So it would be close to some value, but the differences in between the values would be too large or too different in between each other, that all of your is like the relation that your data set holds for one particular relation won't hold true for that another relation if you consider that parameter to be in. So these can be obtained in any number of ways, and this dissimilarity can be bifurcated into groups. So it can be of the ordinal data type, can be based on interval, it can be binary, can be nominal also. So these are nothing but, so now if you know, we have talked about ordinal, there's something as binary, nominal and interval is always fine. Now the first two, this ordinal and nominal, or let's say binary data set, this too, if you say, you always get a group of two things. You always get a differences in between, let's say, two groups. So here you can say that, okay, I can perhaps try and order things around. That's what exact meaning of this keywords mean. So it can be if one is rating something, let's say if you are ranking in between two things. So that is something, that kind of data sets fall in between these dissimilarities where we want to check for the variables. So here they are like checking, I guess this is an example. So they are just trying to order that, okay, which one's the lowest, that would be the one. All of the data set follows one trend, but this is the lowest one, okay, take it outside. Similarly, in between here also, probably would be the highest one, so they took it outside. So this is like, we want to see what the smallest amount of, here they are checking smallest dissimilarity in between these two particular groups, whereas the another group or something else. So Now, to compute this dissimilarity in between a particular group, or what's the difference in between them, if you want to perform cluster analysis in order to see if that particular parameter value is different, there are tests to do so. If your data set is following a normal distribution, that is, if your data set is parametric, then what you'll do is like you'll do this Pearson product moment test, or else it's not, and it's not normal, it's non-parametric, it will follow non-parametric test, so it will do a Spearman coefficient correlation test. Now in here, correlation is simply your ratio of your covariance of any two variables divided by the standard deviation of those two variables. In this case, um, here, yes, this thing is written. In this case, it's given in between two parameters like f and g. This can also in between those two parameters as f and g. There's no such big difference in between both of them. Now, for this particular test, correlation, covariance, these are like integer values. So they always lie in between specific interval as -1 to 1. Another values would be where they are normalized to a particular point. They would be lying in between from 0 to 1. That will look last time also, will look now also. Now there is only one difference in between this Pearson and the Spearman's coefficient. One is it will follow a linear relationship, whereas the another will follow a monotone relationship. Now you will say that okay, monotone is also similar to what linear is, but monotone is actually if one will increase, another will increase. If another decreases, it will also start decreasing. So it's not always a linear relationship. The trend can always be defended is like determined by the independent variable. Accordingly, the dependent variable will also change in that case. So that is how, because of that only we say that okay, that's a non-normal data set which is not following one specific trend, because of which its median won't be symmetric. So your data set is not normal. Okay, so then there's this particular equation for computing your, what do you say, the Spearman's coefficient. Okay. And the distance in between the two matrices, that how you compute the distances there. So this, the formula is like you get a receiver dissimilarity coefficient with is close to 0, whereas the variable with a strongly negative will be considered very dissimilar. So this is how you interpret when you are doing some correlation analysis. In this case, when you're trying to compute the correlation coefficient. Okay, so here the instructor has also done one set of example to show you how to compute the matrices. But it's like, if I like to say that here's like this type of questions are more based on the understanding, not based on calculations. So if you don't even understand how to go forward with this, it's totally fine. But you need to understand what does similarity mean, what does dissimilarity mean. If you are told to say that, okay, if this is my data set, the type of set that is given to me is ordinal data set, how will I try to find a dissimilarity in between this particular data set? There's no need to remember formulas for the same. It's just you need to know here that, okay, dissimilarity means this, dissimilarity means this, nothing more than that. Okay. Now here similarity values are something that are in between 0 to 1. So similar values which have a degree of resemblance in between both of them. So for them, they have a set of conditions where the value lies in between 0 and 1. The index at one particular value would be maximum would be 1. And if they are converted, this value should be similar to each other. This is similar to how you have a diagonal matrix or a equality matrix. Okay. So after that, they are making a similarity matrix for the same, making a resemblance matrix. Again, if it's normal, you'll compute this one. Not normal, you'll compute the other one. These two methods that you have in here. Okay. So this is what the formula for your Spearman's, for your similarity is, that you have 1 plus your coefficient matrix. This coefficient matrix we saw over here, RFG. This is the matrix. If you don't know how to compute it, it's totally fine. No need to stress on that particular method. You just need to know about it. And one more thing, now if you have done, let's say if you're doing standardization of this particular techniques, okay, so you have changed your all of the terms based on this coefficients that is given to you. This is nothing but what we usually used to do was standardization, right? Now after doing standardization of metrics of this type, if we have something as absolute value, and I do for this absolute values, let's say if I do the similarity test, or if I do some dissimilarity test. Okay. So after that, if I try and see the effect on my data set, that effect will go as nil. So the parameters won't be as similar to what they were previously. So you won't expect a effect or a trend in between those parameters if you're trying to take some absolute values. But let's say if you're trying to see some signs in between the parameters, then those trends would be similar. So for this coefficients, hence the signs matter. So closely look at the sign, be sure that, okay, what type of data are you looking at in those cases? Okay. Okay, apart from that, okay. So then you have some binary variables here. They say that, okay, these variables are something like this. You also have a definition for the same in the later slide. That is nothing but if you have a ith row, it's like these are your n number of rows. Okay. This is your columns. So for each and every case, if let's say both of them are 1, your sum of value comes to be Q. If both of them are like one is 0, another is 1, it would be S. Sum of both of them is Q plus S. Same case here and here. Sum both of them is R plus T. Then here, you sum this two, your sum is this. You sum this two, your sum is this. Now you sum all of these here also, you get this P. So what your P would be? Your P is nothing but total sum of all of them. That is P, QRST. So sum of all of these variables. So this one QRST won't be redundant because redundant values, as you see, expectation would become 0 for them. So you only take one particular value for them. Okay, so in this case, if it's a dissimilarity, how do you compute the distance in between both of them? Would be R plus S by total number of values. Now, why R plus S? Because here, okay, I'll just remove the things that we just did now. Okay, so here it was like R plus S. For dissimilarity, what interested into is that something that is not matching your entire data set. It's not something that is actually present and it is true. So we are not interested into that. So hence we are not taking these two values in with us. So one where it is actually true, where it is 1 and 1, where it is actually false, that is 0 and 0. We are actually looking at the sets where it is like not giving us some defined values in there. So that is nothing but R plus S divided by the total number of values. So this is also is like applicable for your data sets which are like ordinal, nominal, categorical, all those kind of data sets, this kind of dissimilarity matrix would be applied to. Okay, then they are giving some example of HIV positive cases and then negative cases. So now in this case, if it's asymmetric, what we are interested into is the, sorry, is the monotone value. That monotone variable can be that a variable that will have your, which is rare to come. That value won't change another and another. So that has not yet occurred. So if you compute the dissimilarity in that case, here it would be R plus S divided by the total number of terms. Because if you see T, it has not occurred only. So we are no longer interested into that parameter. So we just leave that parameter right there. You don't interest, it's like don't even have any interest in between the T parameter. You just continue with like this R plus S divided by Q plus R plus S. That's it. Now if you take a negative out of both of them, what you get is your similarity matrix, and that is termed as that of the Jaccard coefficient. This is not at all useful anywhere, but just this thing based on this particular box and this thing based on this particular box, you should be well aware with that. But apart from that, there are no further questions or examples based on the same, which are actually even relevant for the same. So if in here also you see, it's like they're trying to say if one is true or not. If another is true, they'll compute the similarity matrix for the same. Then they are doing it for a number of values. That's it. It's like for me, I'm like, okay, this is fine, but you don't need to put much effort into it to learn that particular thing. Okay, I hope you guys understand that part. 51. We went to 54 directly. 51. This is part 3. Then you have part 5. Wait, it went. Okay, wait. Then you have 52. So in 52, it's like now just we saw for this categorical variable, sorry, ordinal variables or categorical variables. Now they are trying to show you for this interval scale or binary variables. So it's exactly the same now. Like if you would remember when you had something like n number of, let's say you have x1, x2, x3, x4, x5. Okay, now in this case, your data set will have a median of this. But let's say if you have x6, then your data set would have a median of average of both of them. Or else if now it's even number of counts, then it would be different. If now it's odd number of counts, now it would be different. So in such cases, how your different formulas change, in interval also your formula would change in that way. Okay, now here that's a categorical variable. You see why? Because you have different categories right here. So you have total number of n number 5 different categories that are shown to you. So you should be able to interpret data as and when you look at it. If you don't, if you aren't able to interpret it, it's high time for you to go and directly try and plot the data sets. If you plot it, let's say you plot a scatter plot, you plot a bar graph, your line plot, you'll be able to understand what's the difference in between the data sets. Okay. So here also they are trying to show that the dissimilarity in between objects can be computed based on the ratio of their mismatches. If a total number of the variables that you have, P minus total number of matches that you have. Okay. So M stands for the number of matches. How many matches are there in your data set? So if you subtract it from the total number of values, the rest remaining would be the non-matching data sets. So that is how you are computing dissimilarity over here. So like as I said, there's no need to memorize this formula. It's just directly given to you. It's your normal logic to follow for the same. Now here they'll say, so let's say if I'm talking about object 1 and I'm talking about object 4, I see a match in between both of them. So my formula would have some value. Let's say if I'm now, I'm leaving this object 1 and 4, but I'm interested into 1 and 2. So now if you see over here, there's no match. So then it would be 0. Same way, you compute the values, you make a matrix for the same. Now, this matrix would be nothing but based on your indices. You know how to put this indices? Similar to how you used to do matrix summation. Like this is like 1 comma 1 variable. This is your two, oh sorry. First one would be your row, another one would be your column. Okay, so this is your row, this is your column, row, column, row, column, then row, column. Okay, so this is how it would follow along. So you make a dissimilarity matrix in between them. Then, sorry. Okay, so same thing they have given over there. Now, next is the thing for ordinal variables. So yeah, so how do you order in between variables that you got? Let's say, and similarly, we saw about the genders there. So it was like male and female. So how different those categories are likely to it. Now, if you are trying to do compute it for f number of variables, you order them in respect to those number of variables, and then you do this dissimilarity matrix over there. So you order them accordingly, then you find the number of matches and differentiate it. Now in this case also you'll be able to do some standardization over there. So now this standardization, be mindful that this is not dependent on the unit. Okay, so standardization is not dependent on the unit of your measurements. Your unit of measurements can be different, but if you're trying to compare in between the same data sets or same variables, when you're trying to standardize it, what standardize actually mean that you're trying to make it unitless, essentially unitless. So at that point, it's not at all dependent on the units of your measurements. It's only dependent on the absolute values. And those absolute values after your measurements won't be even dependent, or your trends won't be even similar for the same. Okay, so same way here they have ordered the data set. This ordering would be based on you. How you do that ordering. Ranking can be based on you. If something like this is asked in the exam, they'll probably give that, okay, how you should order the data set. Or it can be, let's say, do a ascending or a descending order, something which is very obvious. After that, what things that you need to do is like find the number of dissimilarity in it, the matches, number of it, similar examples. Okay. Here they have normalized it, made a matrix for the same, identified. Another variable is like ratio scaling. So this will also follow in between your intervals. So you scale it with respect to the ratios. So now they have done some log transformation here, computing the matrices interval for the same. Asymmetric binary, then variables of different types, mixed variables. Then these are like them. Okay. So one where one is your missing value matrix. which is your missing value matrix in here. And delta is 0 if either this is missing, and if either this is asymmetric binary, otherwise it is 1. So there are different cases to compute it. So here, this one such case is for your ratios. Okay, yeah. So if you see here, towards the end, they directly came upon. So this is your range here. That is nothing but maximum number of parameters that you have in your data set. So now here they are actually dependent on the absolute value of your data set instead of the number of parameters that you have. And this is nothing but the ratios in between the data sets at each and every indexes. So your, let's say there we had the distance in between 1 and 2. So you take a difference in between both of them divided by the difference of your entire data set. So the maximum value minus the minimum value of your data set. So you do same calculations there. No actually significance of this equation. Similarly, no significance of this equation right here also. So this is nothing but just to show you how ratio scale variables are. Towards then you do essentially the same thing. Okay. So if I show you one example here, I guess it's not in here. Probably next lecture it would be 53. Yeah, so we were on this particular part, okay? So here, so if they took a particular data set, now they are saying they have already applied log transformation to the values that you'll be getting would be similar. Now, if they have this n number of values, so they found the maximum value in it, they found the minimum value of it. Now you take a difference between both of them, you get something as 1.74. Now, what else is pending for you to do? You take the indexes and the ratios of it, you subtract the indexes from it, divided by the difference that you had, you have your variable value for position number 1, 2, you add it there. Now, this were your identifiers, object identifiers. So this is for your index 1 and 2. So what you do is like you take difference in between both of them. These values come from this particular table. These values come from your range of the data set. Okay. So after that, yeah, you make the dissimilarity matrix again and again. So one might say that, okay, why do you need to do this? Why is it even necessary? So this is necessary when in case you don't have much of your data, you need to prove your findings are somewhere lying, but somehow you end up having any data set that is nothing but as an outlier. So you can't directly say that this is outlier, and there aren't much techniques to identify outliers. So because of it, you can try and what do is like you can try and find the similarity in your data set, dissimilarity in your data set. Instead of not having a significant difference in between your data sets through, what one can do is like they can see how similar your data is or how dissimilar your data set is. So then they can accordingly form or is like form a particular inference for their defined hypothesis or your research question that you initially had in through. So otherwise they do not have actually that much significance in it. Same thing, now they have computed a Euclidean distance. Now he's just showing how to compute Euclidean distance. So this we actually did with
You got stuck.
sorry, actually my internet got dropped. So I wasn't able to be within the meeting. But is my screen visible now? Until what point did you guys hear?
Yes, ma'am, visible.
Okay, okay. So just to go through the slides, so we saw this Euclidean distance, okay? And in Python, we have a direct formula for the same. You can do distance dot Euclidean for the same. But after that, we saw this Minkowski distance where you had a power of p over here and you compress it later to 1 by p. Now, if you do 1, it would be Manhattan distance. If you do 2, it would be Euclidean distance. If you input the formulas, you'll be able to see there is exact similar relationship to your both of the parameters. Now, if you want to do Minkowski distance, directly need to find a Manhattan and Euclidean. There's also ease to you to give the indexes there and it will compute the distances for the same for you. Okay, so you no longer need to add a formula there and compute it. So you directly have a function for the same to do it. Now, if you need to find this dissimilarity matrix in Python, you can compute the distance of the matrix based. Now, this distance can also be based on how particular distance you want to compute, or if not, then by default, it would consider a Euclidean distance. Okay. Now, if you do that, then they have considered some two examples. Okay, you input all of the data set, you have all of the variables against it, you have to weight and height. After that, what do you have? They compute the distance matrix. So after distance matrix, you see this all of our diagonal is 0. What does that mean? This matrix would somehow resemble a lower triangular matrix or a upper triangular matrix. If you see all of the variables right here are also resembling here. Okay. So these variables is also same. So indeed, it's like your matrix is nothing but a triangular matrix that is following some order, whereas it's similar on both of them. So if you see this variable and this variable, it's also similar. So through this data, you can directly say that the distance that has been used to compute is nothing but Euclidean distance and not something else because it is symmetrical. It is directly symmetrical across the line of origin interest. Okay. So then you round it, it's fine. And oh, after it, nothing. Okay, so that's it, I guess. So you get a diagonal of 0 here. And that is how you compute how your data set is along it. Yes, after that we have this k-means, which is very nice part of it, very easy. So what actually k-means is we all looked at it like a method of clustering. Okay. One such method of clustering, which is something which is determined on supervised learning, one can say, or one can say where you are giving some prior data or information to your data set. Okay, so here one already has some prior information about the data set when one is doing k-means. What type of prior information? That is, they know how many clusters they want to group or they want your data set to be clustered through. If I have like a data set of 100 values and I want to split it into two groups. So this group number, if it's known to me, I'll do this partitioning type of techniques. If this number is not known to me, I'll do a hierarchical techniques. It's like here, there's no prior information given. Okay, but if there is some data given and if you want to do this hierarchical techniques, then on that particular value, it becomes quite sensitive if you do this hierarchical techniques. Hierarchical techniques will look in the last week's, so probably in the coming up, I guess coming up Tuesday, not today, we'll just look at k-means here. Professor has not done k-medioids, I guess probably not anymore used, so we'll only use k-means, we'll follow through k-means only. Okay, now what k-means was also a type of clustering, but it will nothing but depend on the centroids. So it essentially is nothing but will compare the mean or the centroids. What centroid is? You have all the three variables, you divide it by 3. So that is what. So you for a particular group of variables, you compute the centroid. If that centroid lies somewhere, for another group of variable, compute the centroid. If it would lie somewhere else, you take a plane of intersection. So you get that, okay, this is my one cluster, this is my another such cluster. Okay. So then how do you choose it? So you have a type of data, your particular purpose to choose both of them. Now, if it's something like that you don't know, something where you actually want to see how your data set would be, you are directly giving it some value into it. There is some graphs that are called as dendrograms, where it's no longer in your hand. So it will cluster it based on its own purpose. So it will do all the clustering based on the data set that is given to you. So this type of techniques are like unsupervised, or one can say them as exploratory. Okay. So one is just randomly pitching into one particular direction and it will sort your data into 2 different groups or 3 different groups. Whatever groups or data, those features are similar to one group, features are not similar to another group. Accordingly, it will do it for you. So it is something similar to how you have a tree and branch kind of structure. So what it will do, it will first find a root for you. Now, if that root is well established, after that, it will start finding one branch. After that one branch, it will see, okay, if that one branch is having some dissimilarity from some another branch. If it has, then it will give it as another such group. Similarly, it will get branch, branch, branch. So those kind of techniques are nothing but hierarchical techniques. So that is why they are also one such graph of them, which is very popular, is called as dendrograms. One can simulate them in RStudio, or Python can also, I guess probably you can do. In R, there's a direct formula for the same, or it's like function for the same. Python, I don't know if it has or not. K-means is like basic technique, but here you need to know the cluster value with you. Okay, so how many clusters you want to be done? 2 minutes. I guess someone's saying something. I'll just mute. Okay. Okay. After that, okay. So here, if you have the number of objects that you have with you, the number of clusters that you want to differentiate it into, the partitioning technique, k-means method. So we just saw it's based on the centroid of your cluster value. So no more than that. Okay. So how it goes through. So this is nothing but it will follow a loop. One can also say that it's a short learning. I won't say actually machine learning, but a very small it's like a very something like a game, a small game to cluster your data set in between groups if you want to. So first you start, you give n number of clusters that you want your data set to be. Now this information is very crucial because let's say you don't know how many type of groups that you want your data set to be clustered through, and you directly give that particular value to your algorithm. It will try and differentiate your data set into n number of groups n number of times. But that information won't be true for you because you don't want your data set to be clustered into that number of groups. So it is highly sensitive. This kind of clustering techniques are highly sensitive to the n number of groups that you are trying to give it to. If you have that information with you, if you know what your research question asks for you can directly go ahead, you compute the centroid for it, you compute the distance in between both of them, then it will group both of them based on the minimum distance that is there in between the variables in one group, variables in the another group. If there is nothing as such, and everything has been moved, it will come to an end. Predicting will also stop. If there, let's say, if your error has also reached a minimum value, if it has reached a minimum value, it will stop. If the number of clusters are no longer known to you and you don't want to differentiate them further, it will also stop. So these are certain limitations that your limitations or conditions that will limit your model of k-means. That after those certain values, it will be stopped. Okay. Yeah. So after one every iteration, what it will do, it will compute the mean value for one particular cluster. For that particular centroid value, it will see the minimum distance for that particular cluster, and then it will segregate them. Just as simple as that. No need to memorize this formula. This is nothing but total number of points in space that you have, and you compare it with respect to the mean of the cluster. So it's just that what we just saw, directly written formula for the same. So here, as you saw, so here there are 3 clusters that they have differentiated, but here they are also trying to show that those clusters can also be something like this. Those clusters can also be something like this. So it actually depends how many clusters that you are writing into. So there might be this n number of cases that would be follow. So one might say that, okay, I actually wanted to do the differences like this, but I got the differences like this. What to do? So in those cases, your cluster value, the parameter that you want to differentiate them through, a very crucial elements. Let's say you're doing some research or something. In those cases, this clustering might mess up your entire conclusion of your studies. So that is why you might want to go through back, decide, understand, bring up the rationale that why you're choosing this particular technique, and then only go ahead. It's not that, okay, it is easy to do, easy to use, so that I'll directly do this clustering technique. Most of the time people prefer unsupervised because it will directly do the thing for you instead of supervised. But sometimes if they know that, okay, if you have the ground truth with you and you know that what you are expecting, then in those cases you can do this supervised thing. First tag your data through and then give the n number of clusters that you want, follow the algorithm for the same thing again. Yeah, so here they are just trying to cluster in between these variables. Yeah, this. So this was for one such variable. Now, if they do it for 2 variables, another, I guess, for 3 variables. So they see that, okay, this is one, this is probably another one such set. If they do for nth, so they say that, okay, these 2 variables are something which are similar. If they increase it, so you see, okay, this group has become one group, another group is like your second group. Then you again increase it, so you make that, okay, this is my one group, this is my second group, something like that. So this is how clustering helps. If you have any doubts, you can let me know, or else we can go towards the assignment hour. That's it for today. It's like, and the Python code for the same is very easy, that you just have to input this parameter. So it's in the sklearn library. So we have went to the sklearn library n number of times now. So that is within the cluster. But if one is using his own laptop and you do not have enough space or something, I would recommend not to have this sklearn library directly installed in your computer, because it's very heavy. It actually has all of the machine learning libraries into it. You can do learning kind of techniques through it. So library is very heavy for the same purpose. It might cause your laptop to heat up at some cases when you're trying to do. So then you import this k-means from the same. You directly give the n number of clusters, fit your data to that particular cluster. It will do that. And then what you want to do is like you directly plot your data. Oh, they haven't shown the plotting. So probably the plotting would be similar. Here, there's the plotting. Then you plot your data. How you can plot the data? Plotting can be similar to one such as scatter plot. And then it can be you tag your data set with the clusters that is being found through this k-means, and you add the values over there. Now, there's also one such score. Now, probably they didn't go through that score, but I would like to emphasize on it. So after you do k-means, you define the n number of clusters, right? Sorry, before you do k-means, you define the n number of clusters. This cluster can be your any integer value, okay? Now, when you do k-means will show you in any particular data set that you're trying to do a set of histograms for all the values that you're trying to do. This set of histograms would be, it would show that how it is differentiating in between groups. Let's say here, if my cluster value was 3, it will show me these 3 differences. Now, what it will do is, it will give me all mean values, the centroid values or mean values for each and every 2 variables. Let's say I have like x1, x2, x3, x4, x5, x6, 7, 8, 9, and 10. What it would do is like, it would give me mean values for all of these cases, all individual cases. Then it will again compare in between opposite values. Okay, something like that. Then this value, this value. It will compare for all of the variables. It will have its own mean values for all the cases accordingly. For will have like, let's say 10 number of values it would have. What eventually you should do, you take an average of all of these values. When you take an average of these values, there's one such score that is called as Silhouette score. You can Google around the definition for this Silhouette score. This score will give you values as 0 point, will give you values in between 0 and 1. It can also be negative, but eventually what you can do is like you can take absolute of the values that you're doing, and it can be within 1. If it's in between 0 and 0.5, shows a very poor clustering, very poor differentiation. If it's in between both of them, good clustering, well enough that you can discriminate your 2 data sets that you want to try to. 1, well and good. If it's 1, what should you do further? You do correlation of your data set. Try and see if your data set is actually correlated to that particular group in which you are trying to differentiate both of them. This way, your data will make more sense and it will help you make a conclusion towards it. So this was one parameter that I actually wanted to enhance through. If you have any doubts, you can let me know, or we can do the assignments then. K-means clustering. Any doubts? So you guys can take your time, can let me know if you have any
हेलो
doubts. Hi, yes.
मैम मेरा डाउट ये है कि जो मेरा एनपीटीईएल का एग्जाम होगा उसमें
Okay.
जो क्वेश्चंस पूछे जाएंगे वो वैसे ही होंगे जैसे हमारे असाइनमेंट्स में पूछे जाते हैं।
Yeah, yes.
ओके, लेवल ऑफ द क्वेश्चन ऑलमोस्ट वही होगा जैसे असाइनमेंट्स में होता है।
थोड़ा सा ज्यादा हो सकता है। क्वेश्चंस पाइथन बेस्ड भी हो सकते हैं, थोड़ा सा ज्यादा कंसिडर कर सकती हो, बिकॉज असाइनमेंट्स और ये वाले सेशंस आर टू हेल्प यू go through the content. Exam would be because there's something as top 10% people who get internships and so on NPTEL के lectures करके, sorry, NPTEL courses करके. So to test that we also need to have a difficulty level to an extent कि we can have those peoples within that particular criteria or set of it. तो थोड़ा सा लेवल ज्यादा हो सकता है बट लॉजिक सेम होगा. सो इफ यू रीड द क्वेश्चन प्रॉपरली, लॉजिक फॉलो करता है तो यू वुड बी एबल टू सॉल्व.
ओके, बिकॉज मैम टाइम आवर्स आई थिंक 2 आवर्स होता है
या यस.
और नंबर ऑफ क्वेश्चंस कितने होते हैं?
100 मार्क्स का होता है यूजुअली, सो नंबर ऑफ क्वेश्चंस अकॉर्डिंगली डिफरेंशिएट होंगे आई गेस. 100 तो नहीं होता टोटल बट ना 100 मार्क्स का क्वेश्चन पेपर होता है.
ओके ओके, थैंक यू मैम.
Okay, so if there are no further doubts, we can go to the assignments. Yes, where did it go? Okay, this is visible to all of you. Okay, so first question. Which library is used to compute distances measuring and clustering using Python? We just saw the distance to compute a distance matrix. So which particular library do we use to compute the distance? It's directly in words. But there is a difference in between a dot and a, that is like, what do you say? Um, underscore. So which library will you use?
B.
Sorry?
B. SciPy Spatial.
No. We just did. It's like it's directly in the words. We want to compute a distance, it would be something related to distance. That's it. So either it's a underscore or it's a full stop.
मैम फुल स्टॉप.
So if it's a function, functions are usually defined as underscore. So it's like distance underscore matrix. Okay. Next question. Formula for dissimilarity computation. So we just did now. If you want to compute dissimilarity, what will you do? You'll find the matches and yeah, so we will know that, okay, towards the denominator, it would be one value, that is total number of variables. We saw P was the total number of variables. So the answer should be within your first option and third option. What it can be? Which one?
First.
Yeah,
First.
exactly. So you take the total number of variables and you subtract it from the number of matches, you get your dissimilarity matrix. Okay. So select the correct option for a data set where you have 7 objects and an interval scaled variable f. Okay. We have the following measurements. F is this, containing one outlying value. So which of the following follows for this? Does the standard deviation and mean have a same effect on the outlier? Mean absolute standard deviation is more affected by the outlier. Standard deviation is less affected. Standard deviation is more affected. Which of the following is true?
Mean
Can I-
absolute division.
More affected by the outlier.
Sorry,
Fourth one is ma'am.
fourth one.
Yes, ma'am.
Yeah, yes. So your standard deviation is more affected by the outlier. However, if someone was saying that the mean absolute deviation is more affected, the mean absolute deviation for SF, we are not looking at it. We want the variance or the difference, the error it will create through the outlier. So the standard deviation would be more highly affected. However, the mean absolute value would remain the same. Okay. Then about the standardization in the following options. So standardization will always give you inefficient result while making clusters, or it will always beneficial during clustering analysis, or the variables which have an absolute value may not be efficient after standardization during clustering analysis, or outliers cannot be detected by standardized data. Which one? Is fourth option true? Just you can say yes or no. Because fourth option directly says outliers won't be detected by standardized data. We can detect, right? Or not?
Third one, ma'am.
Third one, yeah, exactly. So variables, they have an absolute value, which have an absolute value. They may not be efficient after you do standardization when you are trying to do your clustering analysis. But actually, when you have your outliers, if you do standardization, your outliers can be detected. So this is very false that outliers cannot be detected by the standardized data if someone asks you something like that. Okay. Which of the following can act as a possible termination conditions in k-means? So it's for a fixed number of iterations, the assignment of observations to cluster does not change in between iterations.
Which one, madam?
Sorry,
For last previous one, which one answer?
answer is third one.
Okay. Thank you.
So here, except for cases with a bad local minimum, centroids do not change in between successive iterations. It will terminate when your residual values will fall below a threshold. Which of the following is true here?
Ma'am, I think second one.
Which one?
Second one, ma'am.
All 1, 2, 3, 4.
Yeah, exactly. All are true because it will only run for a fixed number of iterations. It would not change in between n number of iterations. Successive iterations also your centroid won't change that much. And if your residual falls below a certain threshold value, it will terminate in that case also. So it's a very simple algorithm. So let's say if I have a curve, something like here that I'll show. And if I draw a line at y equals to 2, how many clusters are being formed here? So if I draw a line over here, how many different types of groups can I differentiate my data into? So this is a line here. Yes. If I make a line like this, I have something over here and I have something over here. Exactly. So this is one such data, this is another such data, because these data sets, they are not at all intersecting this part. So it won't be even be counted. So this is nothing but all of it is counted as one. The one that is above it is counted as another one. Okay, so 2. Next, which of the following clustering requires merging approach? So we didn't do this. The answer for this is hierarchical. We'll look at it and use this lecture. Okay, hierarchical. So we saw this one during the flowcharts. Hierarchical clustering should primarily be used for exploration. True or false?
True.
Yeah, yes, true. So there you actually don't know anything about the data set and you're trying to just explore and going into the values. You're directly feeding it into your data and it will interpolate based on your data or extrapolate based on your data. So you're not giving it anything, you're letting it do what analysis that you want to be. Okay, for finding a dissimilarity in between two clusters in hierarchical clustering. Okay, average link is on, so this is fine. This will look in the next lecture. Another one, this one. If two variables v1 and v2 are used for clustering, which of the following are true for k-means with k equals to 3? Okay, so this is very good. If you have v1 and v2 has a correlation of 1, your centroids would be in a straight line. Or if they have a correlation of 0, they would be in straight line. So what does correlation of 1 suggest?
1 only, ma'am.
Yeah, yes, exactly. If your correlation is 1, then it means that your data set is following one particular specific trend. If that trend is linear, it would be a straight line. Now, if it's 0, how it would be true? Because if it's 0, correlation is 0, there's no specific relationship or any similarity in between two of your data sets. That is why it won't be in a straight line. Okay. So that's it for this assignment. We'll meet in next Tuesday. Thanks for joining today. If someone has any doubts, they can stay back and we'll solve your doubts. Thanks.
Ninth one question is answer is false, ma'am.
Ninth question, yes, that average link, right? Yes, the answer was false.
Okay, ma'am. Thank you, ma'am.
मैम क्वेश्चन नंबर 4 का एक बार फिर से बता दीजिए आंसर।
Question number 4, third option is the answer.
ओके, ओके।
You have any doubts? If not, then we can end the session for here. Thanks for joining.
Thank you. Thank you,
Thank
madam.
you.
Ma'am,
Hi, yes.
yes, any question papers available for practice? Sample question paper.
NPTEL unfortunately does not give any sample papers. What you can do, you can go through the assignments. I guess that should be enough for you to qualify through the exam.
Okay,
Thank you.